What you see here on the left is a chat application that uses account abstraction. And on the right, you see a transaction against the entry point smart contract that is debugged through Tenderly. Now in this video, I want to build this application from scratch using first Foundry for the smart contract development, and then build a Next.js application using Wagmi, Viem, and Rainbowkit. Just a normal application that uses a normal external signer. And then I want to transform this into an application that uses account abstraction to pay for the transaction cost. When I first started with account abstraction, I was completely overwhelmed with the amount of on-chain wallets, different libraries, different providers for bundlers and paymasters, and so on and so forth. And I didn't find a lot of helpful information. So in this video, I want to use first StackUp, then I want to use Candide, and then I want to use Alchemy's account abstraction or account kit. By the end of this video, I hope you have a really good understanding of how account abstraction works, how the on-chain wallets work, what kind of choices are out there, and what you should really pay attention to. Now, this video works a little bit different than my other educational videos. I have recorded my screen for a lot of hours of pure development, and I tried to cut it down to around 1.5 or 2 hours without sacrificing anything in quality or content. But I didn't comment while I was recording, so I'm going to comment now after recording, and I'm going to pause the video every now and then and just make additional comments where I found out after I did the programming that something is important. For me, it was a huge learning experience, and for you, I hope you get the learning experience that I had in the past 2 months, now in the next 1.5 hours. And if you like it, well, like and subscribe. Or let me know in the comments if I made any mistakes somewhere or you found something better. Well, let's get started. If you're watching these videos, you're probably wondering how you can get access to the code, and there's actually a couple of different places where I have the code for you in a nice way, in an interactive way to follow along. The first one is on Ethereum-Blockchain-Developer. If you go to the mini courses and then you go to ERC-4337 Account Abstraction end-to-end development, there is not only the whole tutorial, but there is also an embedded code sandbox dev box. Now, what's a code sandbox dev box? That is a virtual machine that runs on code sandbox's servers and has already the repository, the ERC-4337 chat application repository with the Next.js app and the contracts checked out, and is running Next.js as a dev environment and gives you access to the preview of Next.js. So if you open that up, you already have a fully featured dev environment that is running remotely. You don't need to set up anything. You can also fork this and run it on your own code sandbox and change the code if you want to. Now, I also deployed the Next.js app to Versal on ERC-4337-chatter-next.js-app.versal.app. Link obviously somewhere in the description or in the tutorials. There you have the main branch of the chatter application built out as an actual app. And obviously you get access to the source code in my GitHub. If you go to ERC-4337-chatter-application repository, you can clone that with that command over here and follow along in your own machine if you want to. Now, back to the video. The first thing that I'm doing here is setting up a new Foundry project. I'm doing a forge init and then just giving it a name, and then we'll create a scaffolding project. And the scaffolding project comes with a counter example. There is a script, there is something in the source folder and something in the test folder, and I'm basically just removing it to start with a completely empty project. Now I'm just going to delete that, and I personally think Foundry is still at the moment my go-to toolkit for Solidity development. I like it much better than Hardhat personally. It's just my personal opinion. If you have a different opinion, let me know in the comments. And the next thing is I'm just creating a little chatter contract. So if you think about a chat, you really don't need to store anything on chain. All I'm doing here is emitting an event called message, and this event has 2 different properties that it's going to emit. That is the address that sent the message and the message itself. And then my idea in the chat application is just to listen for these events and then show them on the front end. Maybe give it a little bit of a graphical, nice UI. So instead of the address, give it an icon or something like that. But we will see that later. So the next thing, what I think is really important, is a test. So I like to unit test everything that I'm doing, and Foundry makes it very easy. I put the test in the test folder. I name the test file the same as the actual contract file, just with a T in between. And then you write the test, you set it up, and then you have these little test functions which are executed automatically. And there I'm right now just sending a message, but that's not all. In the next step, I'm going to actually listen for that event. So I have to copy over the event. Unfortunately, I didn't find a better way. And then I am telling the VM that is running the test that it's expecting an event. And it is not only expecting an event, it's expecting this particular event with this particular payload. So I'm saying expect emit, then the event, and then the payload. And now I'm just making the counter example, see if it actually works. And if it doesn't work, then I can drill into that with -vvv for more verbose error messages. Okay, now the next step is to write a script to actually deploy the smart contract. Now I'm doing that. I could do that directly from the command line, but I like to do it in a script. And I'm using a script in the script folder, same with the test, same name as the actual contract, just with an S in between, so chatter.s.sol. And then I am extending my contract here from script, which is a contract from the standard library from Foundry. And I'm broadcasting a new chatter smart contract. You will see in a second how that works. I'm using Anvil here. You could also use Ganache or any other blockchain just for testing. And I'm running the script with forge script and then the script name. And then I'm giving it an RPC URL. In this case, it's Anvil on the left. I say it should broadcast. And the sender is the account that I have in Anvil. It gives me 10 accounts with 1,000 or 10,000 ETH each. And I'm telling it it's unlocked the account, so it doesn't need to ask for any passwords or anything. And I give it a chain ID. So now we have sent the transaction. And the last thing that I want to do is, because I'm working with MetaMask in my Chrome, I want to fund it with some ETH. And I'm doing this with Cast. That's another one of the tools from the Foundry toolkit. And what you see here now, I did run Cast, but I had Anvil started before I ran this recording. So I had still a number in my MetaMask account, which is really bad because MetaMask is caching quite a lot. So if you have these issues, you just need to wait a little bit. It took maybe like 5 minutes, which you don't see in this video, and it updated automatically. I also think sometimes it helps if you just restart Chrome. Well, the next thing here is obviously creating the next application, npx create next app. And I'm using 14.0.4 here, standard parameters using Tailwind and the new app router and all that stuff, obviously TypeScript. And now it's installing the dependencies. And as soon as that's done, we are ready to run our scaffolded or our standard Next.js application. And you should get this one over here. Now it's time to add a Rainbowkit, Wagmi and Viem, which we are doing not with this pre-configured Rainbowkit repository. We are doing it with npm install at Rainbowkit and Wagmi and Viem. And then we have to add these kind of extra configurations into our own project. So instead of just going by the docs, I basically cheat a little bit and I copy the stuff from their standard project into my own project. So I have the provider, which is necessary to have the context and the configs, because there are a couple of components that with the server-side rendering from Next.js that won't work. Now we have a number of providers. We have a number of wallets pre-configured, a number of chains that you can select, and we don't need all of that because we actually want to have an Anvil chain, which we are over here on the bottom left side of the window, which is still running. And later on, we want to connect to Görli. And that's it. I'm not expecting this chat app to run on Polygon or on mainnet. You don't want to pay $30 per chat message. So let's keep it simple. Let's keep it on the Görli network. But if you want to fork it and you want to put it onto the mainnet, be my guest. Just do it. So I'm defining here a new chain called Anvil, just giving it a name. And I will take all of the parameters in order to connect to my local Anvil chain. So that is the network ID, give it a name, call it the network, give it a currency, which is really just anything for the gas token. You can call it anything you want. I call it TETH for test ETH. Give it the RPC URLs, which is localhost 8545. So first of all, the public one, and then it also needs a default one. So otherwise it will complain. And then also give it a testnet parameter and set this to true. So now we have these two networks, Anvil and Görli, and let's save it. And the last part is I just don't need anything of this layout over here. Delete everything and just put in the connect button from Rainbowkit, this component. So if I reload this, well, give it a moment, it's compiling. And then you have the connect button and you can connect with your MetaMask to your local Anvil node. So that is working. And now we need to somehow import our chat application. So for this, we need a couple of things. We need the API and we need the address of the application. So in this case, I am directly importing the JSON file from our Foundry project. However, that is not always a good idea because with type inference from Viem, you would actually get, it can actually infer the types of the events and the functions and the arguments and so on, which it cannot do if you just require or import from a JSON file. So you would have to actually import or export somewhere as const that it works with TypeScript. I'm not doing this here. I just want to highlight it. It's maybe not the recommended way to do it. The way I do it here is just very convenient and much faster. I don't want to set up any kind of exporters or converters or anything. So the next thing is we need to write a message and we need to have a button to send the message to the blockchain, which we're doing now. So I have one input field. I have a state variable message and the function set message, which is going to set the message on change. And then we have a button that, well, does nothing at the moment because we need a function to send the message. And for this, I want to use Wagmi, and I'm using the use prepare contract write hook, which is just preparing a contract write. So it's waiting for any changes in the arguments. And in this case, I'm giving it the chat contract address, the API, the function name, send message, and the argument message. And then I'm using the use contract write hook, which gives me back a function called write. And if the message is, if the user wrote a message, then and click the send button, then I'm going to hit the write function, and this is going to send a message. Now you see that here, it did send the message off, but there is nothing to display the messages yet. So what we are doing now is first getting the events and then listening to ongoing events from the blockchain. In this case, our Anvil node, but later Görli or wherever you want to, it doesn't really matter. So the first part is to get the messages when the page loads the first time. And we're doing that with the use effect hook with an empty array at the end. So it only runs initially, and there we use And there we're doing two things. First of all, we are clearing everything that is in set messages, which is not really necessary at the moment. First of all, we are clearing everything, and then we are going to get contract events. And over here, we are getting all the events from the contract for a specific parameter that is from block and to block. So from block in this case, I'm going to set it to 0, which only works with Anvil. It won't work with the public blockchain, as you can see later. And you have to set it to a big int 0. And then we are going to just simply set the messages, everything that comes back there. It's a log array already. And then we can just output the logs over here, map the messages onto JSX items. So let's do that really quickly. Just output the sender address and then the message. And you will see that works just fine. Of course, it doesn't look really appealing yet, but that is not, just to make it work, it's more than enough. So let's save this. And you can see here the arguments are underlined because it cannot infer that the types, but you see it's working. So let's run another transaction over here. Yeah, if I send another transaction, it won't do anything. I would have to reload the page every time. So I want to use another hook called use contract events. So use contract event, not events. And there I just give it the same address, API, the event name I want to listen to. And then I give it a function called listener, and that gets logs. And over here, I just append the log that I got to the old logs that I already have in my messages. So I set messages, gets the old messages, and if they are set, then it just spreads the old messages array into a new one, and also the logs, because this is giving us a logs array, or it just sets the logs. So every time I send a message now, it just appends it to the end. Fine. What you cannot see in the video is I always get a pop-up from MetaMask. It's just on the other screen that you cannot see in this video here. But every time I click the button, there's a pop-up. Well, the last thing, as I said, it doesn't look very appealing. It's like this is a sender and the message. So I want to use the Jazz icon, and I give you a link in the description below for the library that I used. It just looks nicer, as you will see in a second. And I think those little tweaks to the UI make or break, make it appealing to use the app one way or another. So what I'm doing here is I create an extra component called JazzIcon image. I give it, it has two parameters, two properties, props, one called address and the other one called class name. And then I will just add the JazzIcon image component and give it the address of the sender. And if I want to some class names, then it just looks like, let's hope it's loading, like this. And obviously it doesn't look good, so we have to add a couple of class names. For example, make it round and make it small. And then also make sure that everything is on the same line. So we might want to put everything in its own component. So we create a new component called chat message, which receives the address and the message, which is both the string. And then it just returns a line of chat messages, which in this case is then the Jazz image in a second. And the message. All right, just a little bit more tidy. Now it looks the same as before, no difference. And now we need to make that somehow a flex box, flex line, flex row, sorry, flex column, no, flex row, and give it some gap in between. So that's all Tailwind. I just like to play around with this. And if you don't like to watch me doing that, don't worry, everything is time-stamped for your convenience. You can just skip over to the next chapter and make sure that I have the chapters properly time-stamped on the bottom of the video if you hover the time scale. All right. Now the next thing that I want to do is if you send the message, it should be right aligned, and if somebody else sent the message, it should be left aligned. And also, if you sent the message, it has a blue bubble, and if somebody else sent the message, it has a gray bubble. Basically, like, I don't know, WhatsApp or iMessage. So what you used to from a normal chat application, you send a message, everything is right, and somebody else sent a message, everything's on the left, and it is a different color. It's not a copy of any other chat application. It's just the same UI style. Okay, I mean, looks already a little bit like a chat application. That's too big. You have to containerize that, put it into a container, and make it centered even better. All right. Now we need to add a couple more messages just to make sure that we are not always sending it ourselves. So I'm creating a new script, and in this case I am not creating a new chat application. I'm connecting to the one chat smart contract that we have, and I just send a couple of messages over there. So I'm using the same forge script, and I don't know, wrong directory. In Solidity, you don't need to put the address into quotes. And you can see here our messages that we send from the chat application are right aligned, and the ones from somebody else are left aligned. So from the point of view of the chat application, we are connected with a specific account, and that account is right aligned. That's what I mean. Now we need to make a little bit more of a background color and make it nicer. And more padding, put the icons in the center, make like the right bubble, make the border on the top right, top left, and bottom left, and all the left messages, make them gray, and put the border radius only top left, top right, and bottom right, and leave the bottom left out, so it looks like there's a bubble popping up from the bottom left for the left messages, and a bubble popping up from the bottom right for the right messages. And I'm doing this with a conditional here. So if the address is the connected address, then yeah, it will do it like that. And then the last thing is, I mean, obviously everything is kind of centered right now in the center. You see here, it's very snappy. It immediately reacts. Well, reacts. What a surprise! And everything is kind of centered. And for a chat application, what you used to is that you start from the bottom and you stay on the bottom for new messages, and it will, like when you scroll up, you will stay where you scrolled to. But for when you are at the bottom and new messages arrive, the new message will, like, it will scroll down, if you kind of know what I mean. And you will see this in a second. So it behaves like a normal chat application. And that's actually a little bit tricky to do. There's a couple of tricky elements to that. The one is, obviously you need to scroll down when you are, like, when the position of the scroll bar is on the bottom before the message arrived, then you add the message to this element, and then you scroll back down to the bottom. But if you're not on the bottom, then you kind of stay where you are. And there is a couple of people already solved that. And I'm going to add this over here as well. I'm just going to separate all the different components into, like, all the different items that we have on the page into different components, as it should be. So I'm just making another send message component here, and in a second I will show you how to do this with the scrollable area, so it stays on the bottom. Yeah, so far so good. Everything is kind of working. We can clear up this part and have a send message thing here, and let's just see if that is working. Yeah, it looks good. Great. Let's format this a little bit differently so it looks better. The send message in the bottom, it's kind of like a little input field and the button next to it, but we can do much better. So we can make this a flex, the surrounding element a flex with the full width and a little bit of a padding. And maybe we can add a little border on the top so it doesn't look like it's just hanging in there. It's like a different area of the page that just sticks there. And then make this gray, give it a padding for the input field, and then make the placeholder slightly differently. I'm not sure if I'm really happy with this. It's just coloring. I'll just let the video run for a moment. It's absolutely insane how much time goes into such a small little application to make it look like a little bit better than an MVP, but it's nothing polished yet. It's not something that where I would say, wow, this is really polished, where a designer was sitting down and polishing it. It's just to get a what you would be used to for a decent UI. And I have to say that Wagmi and Viem, with the hooks and everything, that takes off a lot of work, which I had to do previously manually with Web3.js or even Ethos.js. I mean, I never bought into the whole Ethos.js. I kind of got always confused with all the different versions of Ethos.js. So I kind of was sticking with Web3.js right until version 4.0, which I'm not so fond of. No, I was just running into a couple of bugs and then I couldn't find anything in the docs, so maybe it's just me. But Wagmi and Viem, I tried it and it just worked out of the box. And that experience for a developer is absolutely incredible. So what I'm doing here now is I'm going to add that when you click Control Enter or Command Enter when you type, that it sends the message as well. So it's not just, you don't have to put your mouse onto that little button. You can just like write the message and then hit Command Enter and the message is sent. All right, then obviously we don't want to have people write messages while the UI is loading. So we're adding like a use wait for transaction hook from Wagmi. So it is actually waiting for a transaction to be mined, or at least that was my plan, but that's a little bit tricky to do. Anyway, as soon as the message is sent, it will delete hopefully the message, but it doesn't do it because I forgot the value field here. So let's try this again. Yeah, but the problem here is unsettled is actually called before it actually settles. I don't know. I haven't figured out yet exactly when the transaction is settled. So I was talking before about this scroll bar, and there's this component that I link in the description below as well. Obviously, I call it Scrollable Box, and I'm creating this component. but a little variant from it, because I want to not give it the messages itself. I actually want to just give it children, like message children, which are React nodes. So I'm adding as properties as props children and class name. And then we can just add these message children or message components into a scrollable box surrounding those messages. Yeah. And then we are going to make this whole thing scrollable. And it's a little bit tricky. I was playing around quite a bit, and I think I'm just going to speed up the video here, and I will let you see the results in the code that is anyway posted on my website, Ethereum-Blockchain-Developer.com, or I'm going to add code sandbox and the GitHub repository on the bottom into the description of the video. Okay, now this is finished. It took so long because I had a container in the container and the children were wrong. Anyway, so what I'm going to do next is actually deploy the smart contracts onto Görli. And what I'm doing here is I'm using the Frame wallet to deploy using my signer. And the Frame wallet actually exposes an RPC endpoint on 1248, localhost 1248. So you can deploy that using the Frame wallet, which I previously used the Truffle dashboard, but since Truffle isn't here anymore, and I don't want to export any private keys or any seed phrases, I just want to have them in a wallet, I can do that with Frame wallet now. And the problem that I have here is it's trying to deploy the smart contract onto the mainnet. I don't want to do that. I am going into the menu of the Frame wallet and switching it over to Görli, canceling that, and just restarting the deployment process. Now you see here it's a Görli transaction and I am approving it. And I had the verify function in as a parameter inside the command line, which would verify the smart contract automatically in Etherscan, but it didn't do it because I did not have the API key of Etherscan exported on my CLI on my terminal. So it didn't do this, and the same thing is now the problem. It's pending in the queue, and you can actually verify smart contracts like this. And now it's verified. All right, so I have a verified smart contract. You don't have to do this. I just think it's much easier to have a verified smart contract. And now we are going to take out Anvil completely. I don't want to have Anvil anymore as a button inside my wallet connector. And normally I would add all these addresses and all these things to environment variables, but I'm a little bit lazy here, admittedly a little bit too lazy. So I just hard code the addresses and everything. And you see here that when I'm trying to listen to the event and I'm going from block 0, it won't work because it's just too many blocks and it would need an archive node and it wouldn't allow me to do that. So I'm going to change the from block to the block where the smart contract is actually deployed, which is more than enough. But even then later on, it won't work. So I'm later on just going 500 blocks back. And that works. So now you see here, well, it works. You can just interact with that smart contract with your external signer. I'm going to do that here directly via Etherscan with a different account, I believe, or it's the same account. Just sending a transaction to Görli, seeing if that works, if that event is caught by the app, and it is. So I'm sending it by Etherscan and I'm catching it inside my application here. All right. Now we are going to transform this with StackUp into an account abstraction enabled chat application where you don't need to have any gas tokens inside your externally owned account. Now, the problem that I have is account abstraction is a rather complicated topic, and every time I was looking into it, I found that the official docs are either too complex or incomplete for me. So I want to give you a little intro into account abstraction before we are getting started. Okay, now before we are getting started with an actual implementation, let's just recap how ERC-4337 Account Abstraction actually works. If you have a normal transaction like the one we did right now with our chat application, you're going to have a signer, and that signs a transaction and sends a transaction to the network, pays for the gas fees and everything, and then it interacts with a smart contract, and the message sender of that inside that smart contract is the address of the signer. Now, account abstraction, the first step towards account abstraction, or even to make something like account abstraction possible, are on-chain wallets. Now, with on-chain wallets, you are not directly interacting with the contract that you want to interact with. You're making a detour via a wallet contract. So in a wallet contract, you're basically having an owner or somebody who is allowed to interact with that wallet contract and tell the wallet contract to do something in the name of the owner. So in this case, a very simple example would be, for example, I have a wallet contract and that is on the address 0x567 and it has an owner 0x123 and that is the signer over here. And when we want to do an interaction with that wallet contract, then we are not sending the transaction to the contract, we are sending the transaction to the wallet contract that tells the wallet contract to interact with that contract. And then we have a message sender. Inside that contract is the wallet contract, not the owner itself. And there's a number of wallet contracts out there. One that I came across and I'm using very frequently is the Safe wallet, previously called Gnosis Safe. And you can see here in the little screenshot, you are using a Safe wallet, and that Safe wallet is on a specific address, and it's basically a contract, or it's a suite of contracts, but it's basically a contract that you are controlling with an externally owned account with the signer. In this case, there's a MetaMask account attached to it, and then you are just telling that smart contract to do something in your name. And when you own any tokens, any NFTs, any kind of ether, then they are attached to the smart contract on this address, and you are just telling that address to do something. Now the problem is you still need gas in your externally owned account in order to send the transaction to your on-chain wallet to tell it to do something. And this is where account abstraction comes in. Now, to summarize that, an on-chain wallet, it holds the tokens and it gets the instruction from the owner. It can do stuff like multi-signature or this social recovery or any kind of recovery where you have M of N trusted signatures to recover your account and to set the owner to somebody else. Now, let's talk about the actual account abstraction, because those are the things that are necessary in order to make account abstraction even possible. Now, with account abstraction, you are not signing a transaction, you are signing a user operation. And that is a struct that has a number of fields. And when you sign those, you basically just attach a signature from your private key to that user operation struct. And then you're not sending it off to the blockchain, but you hand it over to some other service to package it into an actual transaction and send it off. And that is the bundler. Now, let's say you have the address 0x123 and the bundler has the address 0xabc. And you are interacting with the bundler not via the blockchain. You're interacting with the bundler via an RPC method. They are just offering HTTP RPC methods to send this user operation to the bundler. And the bundler itself is going to package that into an actual transaction, pays for the gas at the moment, and sends it to an entry point smart contract. Now, the entry point smart contract is always the same smart contract for all of the user operations, because the entry point smart contract will unwrap this whole transaction, will look into the user operation, and there is a sender field. And then it will take this sender field and it will send the call data inside that user operation to that sender field. And if the sender is 0x567, and it contains call data that calls a specific function on that wallet smart contract, for example, a function that lets the user interact with the other contract, then it will unwrap that, it will call that function, and the wallet smart contract itself is the one who is verifying the signature of that user operation and making sure the owner sent this, okay, and I'm allowed to call this other contract. Now, you see, it is still a wallet contract, but it is only one more step in between to sign a transaction, which is not a real transaction. It is more like a user operation. It's more like a message to that wallet contract so that the wallet contract knows, yeah, I'm allowed to do that. Great. Of course, then there is also the question how the bundler gets paid and so on, which is not something that I want to answer right now. But suffice to say, the entry point smart contract is calculating all the gas costs and is trying to refund the bundler for his services over here. And it either comes out of the wallet contract that is going to pay the entry point, which is going to pay the bundler, or it comes out of a Paymaster smart contract. But that's way too much for right now. All I want to do right now is I want to see how we can get this private key to sign a user operation, which then gets sent magically to the entry point, which then unwraps this user operation and sends it to the wallet contract or creates the wallet contract if it's not there yet. Now, let's do that with StackUp at the beginning, and then let's do it with Candide and AccountKit later on. Okay, now having the intro out of the way, let's get started with StackUp. And what I want to do at the beginning is, if you go through the docs, you find the UserOp.js, which is a JavaScript package, which, I mean, they claim it is usable with or without StackUp. And it's basically true, but I want to show you why I'm actually not opting to use StackUp. It's a good start, and it makes it incredibly easy to get started with account abstraction in general, because it has these builders. Now, if you drill into these builders, then you will see that there is an account factory, and that account factory is creating an InitCode. And this InitCode is there to create an on-chain wallet in case there is no on-chain wallet yet. So it will call a function create account on a specific address, which is the account factory address. And that account factory address is a smart contract like any other smart contract. And you can even look into that on Etherscan. So if I open on Görli this account factory, I see it's a simple account factory and it has a function create account. And with that function, it will either create a new account based on the address and the salt of the owner, which is a create to method to create the account, or it will just return the simple account later on. Now, internally, it's a little bit more complicated because that factory is actually creating a proxy that then points to the implementation of the simple account. But more than enough, I mean, if you interact with that address that is created by the create account function over here, you will get a simple account on-chain wallet, which is simple. You cannot do a lot with it. You can use this on-chain wallet to interact with other smart contracts. But as far as I know, it does not contain any other functionality like multi-signature or any kind of things that the safe wallet contains or anything else that you want to add to it. It is as bare metal as it gets with as a wallet functionality. So this is why, even though I want to get started with StackUp, later on I want to switch over to another library to actually support the safe wallet. Okay, let's talk about the user operation and these three fields, because I think these three fields are the most important part, which makes the whole account abstraction work. There's the other fields like the gas amount and the gas price and so on. That's there to reimburse the bundler or whoever sent the transaction to the blockchain. And there's also the Paymaster and so on. We're talking about these later, but those three fields, if you understood these three fields, then you basically understood how the whole ERC-4337 works. Now, there's the sender, there's the InitCode, and the Calldata. At the beginning, when you send your first user operation to the entry point, then it somehow needs to deploy that on-chain wallet. And what it's doing is it's actually looking if under the sender address, if there is already a code deployed. And if there is no code deployed, then it would run the InitCode. All right, and then later on, it will run the Calldata onto that sender address, which probably is a smart contract, hopefully, and then it's trying to run that there. Okay, let's talk about the init code. The init code, if you look inside the entry point smart contract, it will call a function, an internal function. At some point, you can open it on Etherscan and you can look at line 337. The entry point 06, by the way, it's not 07. That's currently in the audit, but it will look very, very similar. So it will call this create sender if needed function with the init code over here. And if the init code length is not 0, then it will check if there is nothing deployed on the sender address, on the sender address. So if the code length is 0, and if the code length is 0, then it will call sender creator create sender, and that one is this function. And it's basically just a call with the amount of gas that is available to the factory smart contract, which is the first 20 bytes of the init code. And then the call data, it will just attach the call data to that call. So it's basically a factory.call with the init call data, and then it will try to get the return data back. All right, that's that. Now, if you look at that a little bit closer, and we were talking about this SimpleWallet factory before, then you see that one here is the address. That one over here is the call data. And that one over here is then calling the factory smart contract.create account, because the call data is ABI encoded for a create account, and it gets the arguments that we have for the owner, that it initializes the wallet through the proxy smart contract. This is how the wallet gets created. All right, now we have the wallet. Now there is a wallet running on the specific address, which is the sender address. Then the entry point is trying to run the call data. Now the call data is just, it's using this exec library, but it's internally just doing a call on the sender address, and it's giving it the call data, and it's giving it some gas limit, and it's setting the value to 0. So the entry point smart contract is not transferring any value to the wallet sender. Now, if you remember, if you look at the UserOp.js function there to actually do something and execute a function, it is actually setting the call data from the proxy of the SimpleWallet to the function execute inside this smart contract, and it can have 2 value and data fields. Now the data field is then the ABI encoded data field to send the message to our chatter smart contract, and the to field is the address of our chatter smart contract. So what it does internally is it will call our wallet, it will execute the function execute, and inside the execute function it does something else, which is another call to our chatter smart contract. And it's basically just a wrap in a wrap. So that's what it is. So internally, what you're actually doing is it would just wrap this whole execution of a function call to calling a function in a smart contract wallet to calling a function inside the entry point smart contract. Now there's a lot of validation going on and so forth before that and after that, and there is also the gas amount that is calculated and reimbursed. But this one is the main part of account abstraction. The validation is something I want to talk a little bit later about, but right now I really want to focus on how to get this call data right with the different libraries that we have at our disposal. And we're going to start with StackUp here. All right, first things first. Let's get started with a simple page in a new folder. So I create a new folder called StackUp, and I create a new page inside there, page DSX, and I just output something. And now I kind of need to bring over this account functionality from our normal externally owned account method to our StackUp example. The first thing that I want to do is I want to calculate my address for my on-chain wallet based on the address that is connected with my Rainbowkit. So now I brought everything over, and I want to give the user a choice. So I want to put some sort of toggle or checkbox or something in there to let the user toggle between using the externally owned account to directly interact with the blockchain, or using a bundler and account abstraction with an on-chain wallet to interact with the blockchain. And the reason why I want to do this is I want to really highlight in this example the difference between the account that interacts with this chat application. Because if you're using your externally owned account to interact with the chat application, the message sender inside the chat application that will emit the message event will be the account that is connected to the Rainbowkit, to the connect button over here, 0x5a and so on. But if you are using your on-chain wallet to connect or send a transaction to the chat application, it will be the on-chain wallet's address that is then used as a message sender. So in order to highlight that, I want to use this toggle button. Now, if you're having some sort of application that you write yourself, you need to consider that in the UI design if you even want to give the user the option to use the externally owned account. So for example, the Safe Wallet will merely let you connect your externally owned account to then interact with the Safe Wallet, but you can never, I don't think there's any functionality in there to actually send transactions from your externally owned account to the target at a contract that is then connected to the Safe Wallet. Anyway, so to get started, I'm copying over the presets from the UserOp StackUp page. And one thing that is necessary there is to get Ethos.js somehow working with the whole thing. Let me just copy over the rest of the stuff first, and then you will see what I mean. I mean, it was already there. So you need Ethos.js, and Wagmi actually has an Ethos.js adapter to convert Wagmi to an Ethos.js instance. And what I'm doing here now is I create a lib folder, and inside the lib folder I create the Ethos.js TS file, and I basically just copy the stuff from, you need the wallet client here. I copy the stuff from the wallet client, the whole thing, into this file, and then I'm using the export from that Ethos TS file in my page TSX in order to get to the wallet client. All right, so now I'm using a couple of state variables in order to set the connected address. If the user has the toggle on, it will be the address of the on-chain wallet. And if the user has the toggle off, the connected address will be the address of the externally owned account. All right, so if the user has toggled, if the user has checked that checkbox, basically the toggle on, then it will just set the state variable to true. And if that state variable changed, then it will calculate either the on-chain wallet address, or it will use the externally owned account address in the connected address state variable. Okay, true, false, true, false. Now gets the interesting part. So if you have used Smart Wallet, then we need to calculate the on-chain wallet address. And if we don't have that toggled on, then we just set the connected address to the address of the wallet that is connected to Rainbowkit. Okay, that one can be either a 0x string or undefined. There's a typo over here. Okay. Now in our StackUp example, they actually have a copy, more or less copy and pastable code for getting the address that is connected to the on-chain wallet address. And since useEffect cannot do async functions, I'm going to construct here the promise with then So if I have a signer from use ether signer from this hook that I created earlier, that I basically just copied over from Wagmi, then I can here wait for the promise to resolve. I get back a builder, and that builder is then, there's a getSender function on it, and that getSender function is trying to calculate the function of the on-chain wallet. And when we are going to set that to the connected address, just have to get the types right here, then we should actually be able to output that connected address over here. Okay, there is one thing that is disturbing me here, which is if I toggle that on, I have to sign a message with my MetaMask. And I don't think that it's actually necessary for that to work, because when you can calculate the address of a create2 function without actually sending anything, and I don't need to sign a message for that. So I don't know exactly what is going on in the background there, but definitely that is normally not necessary. Okay, the next part is we want to send a message to our chat application. And in order to do that, we need to somehow fix the rest of the fields of our user operation. And the rest of the fields here is actually just the call data. Because we know where this message will be sent to, it will be sent to our on-chain wallet. If the on-chain wallet doesn't exist yet, it will be created by the entry point. And if it exists, then it will just be sent to that. And then the on-chain wallet will have a function that is called, and that function will then interact with our chat application. And you don't have to take care of anything here. It will be the UserOp library that will take care of, you just have to give it the function that you want to interact with the chat application, and the UserOp smart contract will take care of interacting with your on-chain wallet the right way. Now, one thing that I haven't thought through at the beginning when I was writing this application is all of the components that I meticulously extracted before. That's all useless, because I kind of need to always give it a connected address if I have an address that is connected with an on-chain wallet and not an externally owned account, in order to then make your messages the blue bubbles and the other messages the gray bubbles, and your messages on the right side and the other messages on the left side, and so on. So I need to format a little bit around here. But the point is, there is the connected address that you have inside your application is not necessarily the address that is from your externally owned account in MetaMask or in any other wallet that you have. So now I need to make this backwards compatible as well with the previous externally owned account example that we wrote before. And I somehow need to resolve all of that, because I just copy and pasted the code in there. And it also doesn't like that the block is a specific block. I would just change this to the block that is the current block minus 100 or 200 blocks. So let me just see what's going on here. That one returns actually returns data, not a block number. Just give it I call it data now. I call it block number now, the data. And what else is the problem? It can also be undefined. So make no mistake, you need to actually make sure that when the block number changes, that you also call this useEffect hook. Why it works in this particular recording, I'm not exactly sure, but it works. And I have actually fixed that at the final example. When you look into the Candide folder and on the page TSX, then you will see it actually is the fixed version that you will get as code example. All right, so now if you are going to send that message, it constructs the message correctly, but it needs to be sent off with the right method, because right now if you're hitting send message, it will just use MetaMask to send the message, but we actually want to use that one over here to then not only construct the call data, but send the whole user operation to the bundler. And I signed up to StackUp before. I got an API key for the bundler, and I got an API key for the Paymaster as well. And the Paymaster in this case is kind of important because if you don't have a Paymaster, then the wallet smart contract needs to pay for that transaction. And the wallet smart contract needs to be funded first if you have no Paymaster. So there is a function inside the entry point that gives the wallet smart contract actually a number of Ether it needs to transfer to the entry point so that the entry point will continue to work on the whole transaction. And if it doesn't do it, it will just stop there. But it will not even go that far because the bundler will first simulate the transaction and will find out, wait a moment, the wallet smart contract will not send me any funds back, so I'm not going to send these transactions because why should I pay for the gas costs? Because actually the bundler has the gas costs. So you need either fund your address of your wallet first, or you need to have a Paymaster. In this case, I think I had a Paymaster here already without even exactly knowing how this works. But let's finish building this, and then I will run this transaction through Tenderly, and we'll show you step by step what's happening inside that transaction. Yeah, so in this case, I have the builder at the beginning from useEffect, and then I just want to set the builder as state variable so I can use that builder that built the address of my SimpleWallet to send the transaction. So I have this over here. I don't need any of this. I have the call to is my chatter address, and the data is the ABI encoded function data that I used a function here from Viem. And then I do a client init with the RPC URL. The RPC URL is the bundler from StackUp. And then it will ask me to sign that transaction with MetaMask. And then it will send the transaction and will give me a transaction hash. So let's just see what happens here. I think I wanted to wait for the transaction to be mined, but I don't really care. Okay, here's the first sign, and then I'm going to send a transaction. I have the message hash. There's something going on, and it says it didn't pay the pre-fund. So the bundler actually gave me an error message that I didn't pay the pre-fund. So I'm going to fund that wallet now. I have a little bit of Görli ETH in my account, and I'm going to fund that wallet now. Now, obviously, you will say maybe, wait a second. Why would I need Görli ETH in order to fund something? I thought account abstraction is the whole point, that you don't need have any Görli ETH. Now, I don't have to have it in this account. It can also be somewhere else. Now, this is also where the Paymasters are coming in. If you have a Paymaster, you can actually pay for a user that doesn't have anything in his account, because the entry point will look, is there a Paymaster attached? And then it will ask the Paymaster, do you want to pay for that transaction? And if the Paymaster pays for the transaction, the smart wallet doesn't have to have any ETH or any kind of funds in his own wallet. All right, what you see here is Jiffy Scan. Etherscan cannot deconstruct any user operations yet. I'm using GiffyScan for that, and GiffyScan will actually give you, for a user operation hash, which is different than a transaction hash, the contents of the user operation hash. And now what I'm also doing here is Görli. What you see here, it's basically just a transaction against the entry point. And the entry point, as I said previously, is always the same smart contract, always running on the same address. It's like this 0x5ff and so on. And you will see, if you go into that transaction, the message from our chatter application is actually emitted. And this is what our chat application gets back. That's the message. All right, if this was a little bit too fast, then I suggest go back to the code sample that I posted and check out the StackUp example. It's all there. You just have to go in and follow the code and see what happens. Yeah. This one is the user operation. You see the sender, which is my on-chain wallet. And this one is the entry point smart contract. And it goes directly into the handle UserOp and calculates then through all of these functions. It always calculates how much gas was used, and did the wallet smart contract pay the gas in order to pay back the bundler. And then it basically just calls the sender with the call data. If you leave out all these gas calculations and so on, what it basically does is it takes the user operation, it takes the sender, it takes the call data, and it sends it to the sender, and it executes this function. That's basically what it does. There's nothing much more behind it, and the rest is gas calculations. Now, the function that it calls on the SimpleWallet is the execute function. And this execute function, or it calls the execute batch function if you have an array of to and data values. And if I go into my SimpleWallet, which in this case is unfortunately a proxy, but if you go into the SimpleWallet itself, I need to find where it is, because that's what I want to show you. Yeah, here's the simple account. And if you look, if you scroll down a little bit, and then you will find the execute function. Here's the simple one, and here's the execute function. And the execute function, really, the call data of the user operation is an ABI encoded execute function with the parameters. That's what it does. And this is how it gets onto this on-chain wallet. Now I'm going to attach my Paymaster here. And what you will see is that you don't even need to have any kind of money inside your on-chain wallet. And I'm going to send a transaction from an account that has 0 Görli ETH. And I do not fund my on-chain wallet before I'm going to send this transaction, and you will see it still works. Yeah, it actually did pay for the transaction. Let me just switch over to a different account that has no Görli ETH. 0 ETH in my account. It's a different address. I'm not going to fund it. And I'm just saying, hello, 0 ETH account. Sending this one, and it's waiting for the transaction. Come on. Send the transaction. It sent the transaction. I have a transaction hash. And if I go back to my dashboard of StackUp, I will see that my so-called pay-as-you-go Paymaster paid for the transaction. Let's just have a look what was paid here, and so on and so forth. So there's the Calldata. Sorry, there's the Paymaster and data that is then called from the entry point smart contract. And if I'm just gonna refresh that, then you see it actually paid some gas costs. So if I would use this Paymaster now in a real life scenario, I would, like if I would use this Paymaster from on mainnet or on Polygon, I would have to have my credit card there and it will directly pay me. Before we're gonna continue with Candide, I promised you to look into the transaction with Tenderly. And before we're doing that, I actually want to talk about the rest of the fields of the UserOp. In particular, I want to talk about the gas fields, where they are coming from and how they are used. So when we are talking about the transaction later, that you see where these are used and what happens with them actually. Now, I found it a little bit confusing why I need those fields, but they have a very specific reason. But let's first have a look where they are coming from. Now, the gas limits, they are estimated through the bundler. With StackUp, you didn't really see that there is an estimation running in the background before the transaction is actually sent off. Now with Candide, it's a lot more low level, and I think it's a lot more understandable what happens behind the scenes then, where you have to estimate how much gas will a transaction actually incur. The bundler itself gives back a call gas limit, a verification gas limit, and a pre-verification gas. So the bundler internally will estimate the gas amount that is used up by the transaction, and then give it back to you, and then you have to add this to the UserOp yourself before signing the user operation. So those are these three fields: the call gas limit, the verification gas limit, and the pre-verification gas. That's the amounts that you get from the bundler. But the max fee per gas and the max priority fee per gas, those are actually current block gas fees. So when you call any public client and you say like, hey, what's the max fee per gas and the max priority fee per gas at the moment in the block? So those are those values. And then you add those, and then you check the nonce. If the nonce is 0, then the InitCode must be set. If the nonce is more than 0, the InitCode cannot be set. And then you add the signature, you sign the whole thing. This is where MetaMask pops up and the signature happens. Now let's have a look into an actual transaction. What happens? This is a random transaction that I just took from Tenderly against the entry point. It is obviously against a safe wallet here, so you can disregard that because we are mainly talking about the entry point functions that are called over here. It's running through a number of steps. The bundler itself is called with a user operation and a beneficiary. And the beneficiary is actually the one that gets reimbursed at the very end of the whole transaction. It starts with validating the prepayment. That is where the entry point decides, okay, based on the gas amounts that the user gave me in his user operation, how much money do we need to reimburse the bundler or whoever is the beneficiary at the end of this transaction? And it will either ask the wallet or it will ask a paymaster if there was a paymaster and data attached. Now, there is then a validation phase that is validating the user operation. And this is where, when we open this up here, after create sender if needed, it will call this very strange 0x3A871CDD function signature. And that function signature corresponds to validate user operation. And that validate user operation is not happening inside the entry point. The validate user operation is actually happening inside a wallet, an on-chain wallet. Now I have this screenshot over here is from the base account from the ETH Infinitism repository. It's the current develop branch. And inside there you will find validate UserOp. And it takes a user operation and a couple of other fields. And then it will, if you deploy a wallet with that base account, then it will check first, wait, is the transaction from the entry point? Is the signature correct? Is the nonce correct? Then we are going to pay our entry point whatever it decided that account funds are missing. So it will check the signature and it will pay from its own funds. And the entry point will set this to greater than 0 if there was no Paymaster attached. If there was a Paymaster attached, then the Paymaster will pay for the funds. Okay, now we made sure, first of all, there is a wallet created, and the wallet validated the use operation, and the wallet potentially even paid for whatever was the total of all the gas amounts times the block gas fees. Okay, then it continues after this whole validate account prepayment is done, and the entry point knows that the signature validated through the wallet, the funds are here deposited inside the entry point. Now we can execute the user operation. So it goes through the execute UserOp function inside the inner handle UserOp function inside the call function. And over here is exactly what I showed you before. There is a call to the wallet, or the address that is given as the wallet with the call data that was there, with the call gas limit that the user decided inside the user operation. That should be the maximum call gas limit for the call of this call data inside the wallet. Now, when all of this is done and it successfully comes back, or maybe even not successfully comes back, and a Paymaster was used, then it will try to reimburse or actually recalculate how much gas was actually used during that whole transaction, in case the Paymaster overcharged a little bit, to make sure that there is really enough money inside the entry point to go through the rest of the transaction. And then at the very end, it will reimburse the beneficiary that was given to the entry point at the first calling, the amount that the gas amounts, the sum of the gas amounts times the block gas limit. So it will get back what was given inside the user operation. There was an interesting question from a user that was like, what happens if I set the block gas amounts to 0? Now, the sender will not get anything reimbursed. This is what happens. This is why when you send something through a bundler, it will also check the values again inside the UserOp and make sure that it actually gets reimbursed something, and potentially even more than the actual transaction costs. So there is no real connection or no validation between the bundler is sending a transaction with 20 GWI, but the user operation says it should be sent with 50 GWI. And then the bundler gets reimbursed for the gas amount times 50 GWI, but it actually just spent 20 GWI. So there is a disconnect between that. And the bundler can or cannot send this with whatever gas amount it deems to be correct. All right, with that being said, let's continue with Candide. I think you will like it because it's a lot more low level and you will see the exact steps that are happening with the bundler and the Paymaster. Now, the problem is I didn't get with StackUp the safe wallet to run. And the safe wallet that I have here is, I like it so much because you get a really nice UI to interact with your on-chain wallet. You attach your MetaMask or other signers to your on-chain wallet, and then you interact with your on-chain wallet through this UI. There's apps that are integrating with iframes, for example, on-ramps, off-ramps, DeFi apps, and so on. But you need to create the safe wallet with the account factory of the safe wallet. And the only library that I could find which is doing that correctly is Candide. Now, Safe Wallet also has account abstraction, but it's not this account abstraction. They are using a service called Gelato, which then does gasless transactions, and you are interacting with your on-chain wallet through the help of Gelato somehow. Now let's get into Candide. Because with Candide, we can actually use safe accounts to deploy a new safe Gnosis safe account instead of a simple account. And I just want to do the same thing. I want to create a separate page, and I want to use account abstraction with Candide in this case. Heads up, there will be a change to both Candide and the entry point. So there is, at the time of recording this video, there was just a new entry point version posted or handed over to Obzeppelin for audit. And at the same time, I'm in touch with the Candide team, and they are just writing a new version of the Candide NPM library. So there might be some updates. However, I do think the basic principles of how to apply account abstraction with Candide still apply. So follow along, and I will try to keep the code updated once a new library comes out. Alrighty, the first thing that I'm doing here, as before with StackUp, I'm going to create a new folder, and I basically just copy over the whole page from StackUp. Now a little bit of cleanup, and then you will see here on the left side that I want to use a specific branch from Abstraction Kit, and that's the safe branch. Now the problem, if I just do an npm install and I want to use a specific branch, it doesn't work. So I kind of need to install a specific branch directly from GitHub. So npm install abstraction kit at safe doesn't work. So I kind of try to install that with the HTTPS version of the repository. So npm install https github.com/candide-lab/abstraction kit, and then at the end the safe branch in here. Now the problem is here that it will download the rest of the node modules inside the abstraction kit, but somehow it doesn't have the dist folder or anything else. So I'm kind of a little bit lost here how to do that correctly. So what I'm trying now is to just make a new library folder and clone the whole repository locally, and then try to link it from a local repository into the node modules folder. So I have it there, and I think it will just be a symlink or something. I do not think that you will need to do this when the new version of Abstraction Kit with the safe module is actually released, because they will have it in there. You see, npm install doesn't work, and I think there is an npm link, and then I opted just to add the whole thing to my package JSON file, and then just do an npm install, and that did work. So just give it a minute. Yeah, again, I don't think you will need that. Try first to just install the abstraction kit and see if you have the safe wallet or the modules for the safe wallet inside there. So I'm opening now the package JSON, and I'm saying, okay, for this abstraction kit, just use the file lib abstraction kit, and that actually worked. So if I go to the node modules folder now, I have the abstraction kit here. There's the source folder and so on and so forth. And now I need to check out the safe, the Gnosis, the safe branch with the Gnosis safe, and I can continue. And later on, you will see that I also needed to run npm run build, I think, inside the folder to actually get the dist folder. Otherwise, the IDE VS Code will complain that it cannot find abstraction kit. All right, so it's trying to import this from source, but I just leave it like this. At that point, it was, yeah, over here. You see npm inside the lib folder, inside the abstraction kit, I run npm run build, and then it will create this dist folder, but VS Code will still complain, and I don't know exactly why, but it works. It finds it from Next.js, and it can compile the whole Next.js app. So I think that is fine. So I'm going to continue here from now. And now it's basically what is in the docs, that is getting the safe account and calling this create new account with the address of our externally owned account, which is in this case my MetaMask. And what we are getting back is the account address and the init code. So the whole builder and everything and the Paymaster, middleware and whatnot from StackUp can go, and we are just setting the new account address to the one that we're getting back from create new account on smart account. So if I go to Candide, and you see here, first of all, I don't need to sign. And second of all, it's really blazing fast. So this is what I was actually expecting at the beginning when I was using StackUp. But for some reason, it uses the on-chain version of the create2, and then you need to sign the message hash and so on and so forth. Anyway. All right, we are continuing. We just have a look at this. We don't need that. We actually want to store the InitCode somewhere because we are going to need that InitCode to create Calldata single transaction, which is what we want, which is then calling on our safe account, on our smart account, the execute function with the data that we are giving it. But if the safe account is not there yet, it needs to be created first, which means we need to have that InitCode delivered to the bundler. All right, I'm just basically using a state variable and setting that wallet InitCode. All right, getting the operation, and now we can do create Calldata single transaction. And we already have a Calldata there, so we don't want that. However, the data here inside the Calldata single transaction must be the encoded function data to our send message chatter ABI chatter smart contract with the message. So in this case, the bundler is going to send a call to our smart account, and that smart account is going to execute a call to our chat application send message, and this is how it gets in there. I'm going to import the bundler from abstraction kit. I don't know why it's doing that, but so be it. So we have the RPC URL. Interestingly enough, I'm still using the RPC URL from StackUp. I'm not using the RPC URL from Candide yet, which is this voltaire.candidewallet.com RPC endpoint. But it did work at the beginning. I'm not sure if I'm gonna change this here now. Either way, the bundlers are intercompatible. So you send stuff with one bundler, it also works with the other bundler, most likely. So if they are getting enough money reimbursed from the transaction, then it will work. Now we are talking about gas estimations. So what we want to do here is estimate the amount of gas that we gonna need in order to send this transaction. So first is the bundler gas estimation that we talked before. And then it is the block gas limits that need to be added to the user operation before it can be signed. So first of all, we need an empty user operation. This is this one. Right now, we are setting the nonce to 0 and adding the InitCode no matter what, because we assume that the first transaction is going to be a nonce 0 transaction. Later on, you would need to query the nonce from the entry point. You can find it in the final code example that I have. And then set the InitCode if the nonce is 0, or set nothing at the InitCode if the nonce is non-zero. All right, we are getting back over here a couple of values for the call gas limit, the pre-verification gas, and so on. What I'm changing here is the 2B hex from Ethos.js to 2 hex from Viem, and just outputting this. Oh, where are they? They are currently 0, and I'm a little bit confused here, but I will find it in a second that we actually have to set these to the user operation. All right, now we are getting the feed data from the public client. We're getting back max fee per gas and max priority fee per gas from the public client. And for that, we either need to import the public client first. The public client, get public, use public client hook from Wagmi. It's going to give us the public client. And then on this public client, we can get the feed data. So it's basically just copying this one and then just outputting the feed data and setting the feed data to hex numbers from max fee per gas and max priority fee per gas. I think there's a typo in the documentation of some sort. See. I have not set the smart wallet to true. And now we get the feed data back. So we have big number. Those are big number literals with 15n and 2n, in case you're wondering. And I'm just checking if the UserOp is having the right values over here. And I just saw that there's a typo. So fix that one. And we are ready to sign the whole thing. Yeah, it's basically sign and submit the transaction. Again, we have no Paymaster attached here. So if there is no Paymaster attached, then the wallet must pay for the transaction. That means we need to fund that whole, the wallet first enough so it can pay for its own transaction. And let's just get the user operation first over here, the user operation hash. So it's the hashed version of the user operation. And then we need to sign that with our MetaMask account, with our externally owned account. Let's just check if the user operation hash is there. It's there, and now we need to sign that with our signer. And for that, we are using Viem, not Wagmi. We are using the Viem version on the wallet account, the sign message, and there you need to have the raw message. So getting the wallet client. Because we're not doing any Ethers.js things. We don't need that Ethers.js signer hook. We need the wallet client from Wagmi. And on that wallet client, we are going to call sign message. And the argument here is the message and the raw message. Otherwise, it will just prepend that Ethereum message prepend thing, which we don't need that. We are doing account hoisting, and that is the user operation hash. Let me just make sure that we get the types right. Okay, there we have a signature. Let's see if we can get that signature. And so far, you see the only thing that really needs to be signed is the user operation. So, and actually not the user operation hash needs to be signed. So there is really just one signature that we need to create, which is the one for signing the user operation before sending it to the bundler. It's called the connected address, format everything, and give it a go. Sign this. Oh, we didn't fund our wallet. First of all, it's Görli over here and not Sepolia. But that's a small thing. Let's fund the wallet so it has enough funds to pay for creating the wallet and running the InitCode and running the Calldata. Takes a little bit. And as soon as the transaction is mined, we can actually then hopefully send this transaction, interestingly enough, through the bundler from StackUp, not through the bundler from Candide. Right. Well, we have a message over here, and we can input the user operation hash inside Jiffy Scan, and we see everything is kind of there. It's working. Great. Yeah, we have the sender. That's this account. We have the target, which is our smart contract for here the message, the chatter smart contract. And we can see the transfers of ETH back to first from our wallet to the entry point, and then from the entry point to the beneficiary, the bundler. And we see the user operation over here. Yeah, everything is there. Now, the other thing which we can do is we can add our safe account to the app.safe.global website. So it's that account over here. It's automatically recognized by the website. And there's an update to Candide. At the moment, when I was recording this video, there was something going wrong there that I couldn't interact with my safe account, but it should work. And I was assured that it will work again. Yeah, but basically, when you create this safe wallet via Candide, then you are creating an actual smart contract that conforms to a safe account, or should conform to a safe account, and you should be able to use that wallet inside the app.safe.global website. All right, that's it with Candide so far. Now I want to go on and try the account kit. Alrighty, now let's get started with account kit next. We just need to install Alchemy account kit AA-Alchemy and so on. Then basically run through that getting started guide, and we should have pretty much the same as with Candide. Now there is a major difference here, because account kit is producing a simple account, or a light account, which they call. And that light account is optimized for gas usage, as far as I understand, reading through these documents. You can bring your signers and so on, but you will get a light account. And I think they made some sort of effort to give other people the opportunity to add their own wallet integrations, but I could not find a safe wallet integration, which I was personally after. So if your use case is to have an account which is gas optimized, then you might want to go with the Alchemy Lite account. If you want something which is more low level, and for me personally easy to understand, go with Candide. If you want something super high level and abstracted, where you basically just give it your credit card and need a simple account integration, you can go with StackUp. I mean, all three services were working correctly. That I have to say. However, if you need some specific things from these services, like a safe account or something, or you don't want to use Ethers.js at all, for example, you cannot go with UserOp JS from StackUp. You might get away with Alchemy's integration from AccountKit here, but you definitely get away with the one from Candide because it's very low level. You can do on the integration side with the wallet whatever you want. All right, the other thing that I tried to set up in AccountKit or in Alchemy is a gas policy. So I wanted to create a Paymaster and test that over here. However, I couldn't get it to work. You will see this in a second over here in the video. Every time I was trying to create a Paymaster or create these gas rules for the Paymaster, it errored out, and I didn't want to go so far to actually create a paid plan. Maybe that was the issue, but yeah, I couldn't use a Paymaster with AccountKit. So maybe there's something going on. Maybe Alchemy will tell me where I made the mistake, or maybe it was a UI issue, a temporary one. It shouldn't stop you from testing Alchemy as well. All right, let's get started with Alchemy. Yeah, let's get actually into that app. Into this dashboard, log in, run through the init setup, and create. You can use that API key straight away, or you create your own project. So I always recommend putting things in environment files. In this case, you would put it in a Next.js public environment file and so on. But I just recreate the same thing as before, create a new folder called Alchemy. So it's a route/Alchemy, and then copy the page over from Candide and get started from there. If my Alchemy integration doesn't work anymore, it's probably because I deleted my Alchemy project with the API key. You would have to add your own API key if you want to make it work. So the gas manager. The gas manager first had an internal error. And then I was reading through that whole thing somehow. And there's a generous free tier for the bundler. And there's a fee logic and so on. But it really comes down to creating that Paymaster rules, which didn't work. So I'm installing now the Alchemy's AccountKit libraries and run through that getting started page here. So importing those things. Don't need to have the abstraction kit things anymore from Candide. Need to create that provider. In order to get that account address from our wallet. So it's complaining that the owner needs to be a wallet client. So we need to create a new wallet client signer. To import that. And then we get the address from our provider. And that one is hopefully the connected address that we are getting. And now we need an API key. So I'm getting this API key over here. Great. Let's save everything. And see if it's working. change the chain to Görli. Yeah, and you can see here it is calculating something internally. It takes a little bit until this account is created or the address is calculated. I'm not sure exactly what's going on behind the scenes, but it's definitely not as snappy as Candide, but better than StackUp in this case. So the next thing is to actually send a user operation. And again, this is abstracted away inside a send user operation function that most likely internally does everything that we did with Candide before inside our page TSX. Now it's doing that inside this provider.send user operation, probably getting the gas estimates, the gas fees, and creating the hash and setting and signing the hash with our signer that we gave it inside the provider creation. So I'm just setting the call data to the call data for send message. And we don't want to give it any value. And then we get this hash. That is not the user operation hash that we need to sign. That is the user operation hash that is already sent through the bundler. All right. Still complaining about some brackets set wrong. There we go. So what will happen? Need to sign this, and we need to fund our wallet before we send this. Okay, same as before. We are funding our wallet. And as soon as the wallet is funded, we can retry. And we have a user operation hash. Let's see in Jiffy Scan if that was actually sent. Yeah, it was sent. So the last thing that we can do is we can wait for a user operation transaction. And what this does internally is it calls the bundler for the status of the user operation. And if there comes something back, then it resolves that promise. And if there's nothing coming back, it will just retry with a staggering timeout. So it's not overwhelming the bundler. So the other thing is here, the internal gas estimation failed from Alchemy's account kit, probably because somehow the gas amounts changed in between one block to the other. And then it also gave me another error, but the transaction worked. I don't know. Something was going on in the background and I didn't know exactly what. All right, here we are in the gas manager and I'm trying now to add a gas policy. So I'm just creating this policy, trying to select an app, but I didn't create an app yet. So let's create a new app for Görli. Just call this chat app. And actually use that API key for my bundler. I don't need those addresses anymore. All right, create this new gas policy and next. And then I'm trying to just limit this to 5 operations per address, but somehow, no matter what I clicked here, didn't work. So we reached pretty much the end of this video with that. And the last thing that I want to talk about is the Paymasters. And there's 2 things that I want to talk about. One thing is I did another 2 hours recording of how I formatted and better formatted the Candide example into an actual chat application so that when you send a message, It will add a temporary message, and you have some nice little status icons to know where in the whole process between estimating the gas fees, signing the user operation, and getting back the result and waiting for the transaction to be mined. You have nice little status icons. And I added a Paymaster. And the Paymaster is one thing that is actually quite easy to implement. But there's a huge fuzz around this thing. So I just want to give you an example of how a Paymaster could work. As promised, the last part of this video, and I want to go through a couple of things that I changed inside the Candide example over here. And you see over here on the left side is the final version of the chat application that I'm going to post into the code examples. So you see here the little icons. First of all, I made the message already appearing inside the messages before it's actually sent. And then when there's a signature or we are waiting for the transaction to be mined, it will keep it there. And then when the actual transaction is mined, it will replace this message with the actual log message that comes from the smart contract. Now, in order to do that inside the send message function that I have inside Candide, I have a couple of things going on there. And you see it's not working perfectly, but it's good enough for this chat application. I'm just setting a pending icon over here every time something changes, and I'm using this pending icon inside the message history component. Message history component is over here, and then there is like a pending message which is set. And if the pending message is set, then I would just use this pending icon over here and set an extra chat message to this pending message that is set as pending when we are writing something over here. You see the icon is changing, and we get a nice little UI that's working. I also changed a couple of things over here. So I have an externally owned account method, which is the pure method with the wallet that is connected through Rainbowkit, and I have this button to change it to the smart contract wallet method or ERC-4337 method, which then uses Candide. The other examples should still work, but I found this one the most nice one for me, so I started to actually build it out into a little better application. Now there's the one thing. The other thing that I wanted to talk about is the Paymaster. I'm using the Paymaster from Candide over here. If you sign up with Candide or with Alchemy or with StackUp, you get an API key for a Paymaster. And the way this works is there is a smart contract that gets called from the entry point, and that is going to pay for the transaction because the Paymaster and data field will also contain a signature. So if you're calling the Paymaster Candide validation Paymaster, get Paymaster Calldata for Gasless transaction, which is a new thing. I'm not sure if you can actually get public access to that yet. Join the Candide Discord if you are interested in that. You find it on the Candide website. The guys are very responsive, very nice people, and I'm also hanging around there if you have any questions. The point is, you will get a struct that the Paymaster smart contract can deconstruct, and it will also contain a signature that is signed from the Paymaster team, from the Candide team, so that the Paymaster knows, okay, this is really from the Paymaster, from the Candide team, and will pay for the transaction. In the background, getting this is an RPC call, an HTTP RPC call. So there is a normal HTTP interaction first, but it doesn't have to be. So you can also write Paymasters, which are just smart contracts, which are, for example, converting ERC-20 tokens to ETH or to Matic or whatever the gas tokens are on the blockchain you're operating, and then just paying for that. And there is a new entry point coming, entry point version 0.7. it looks like this. It looks very similar to the previous one. The big difference is there is a new Paymaster, and if you go to the samples inside the develop directory for the new entry point, then you can actually find two different Paymasters. The one is a verifying Paymaster. When this one gets called from the entry point with validate Paymaster UserOp, which is in the base Paymaster, it will internally call the underscore validate Paymaster UserOp with a packed user operation UserOp and so on and so forth. It will actually check the message hash that is given as a signature to the Paymaster and data. So that one needs to be generated outside before the user operation is actually sent. But it can also be a token Paymaster, which means that when the validate Paymaster UserOp is run, it will just take a cached price or some price and do an ERC-20 safe transfer for the token from the sender, from the wallet address to the Paymaster address, and then just pay for the transaction, because the Paymaster is just doing that. So there is no interaction from an external entity necessary. And you could even go so far that you write your own Paymaster that pays for the transaction no matter what. You get the whole user operation, so you know what's being called. You can deconstruct this if you want to, and you also know how much funds are required. And at the end, the post-op function is called with the context that you give it before over here, so you can actually give something back to the entry point, and then in the entry point it runs through the whole user operation, calls the wallet and executes whatever call data is there, and then goes back to the post-op, and you get the context back, and then you can, if something is overcharged, undercharged, you can transfer more or less something back and so on, and give the actual price that needs to be paid to the beneficiary, most likely the bundler, then back to the entry point. All right, that's it. I hope you liked the video. I hope account abstraction is now a lot clearer than at the beginning, and I hope I will see you in one of my courses. You see here, that's the app that we wrote. I will make sure that you have all the code samples and everything ready. If you're looking for something to learn Ethereum, then one thing that I created is the Ethereum-Blockchain-Developer site with a couple of courses. I will also make sure that this particular video is posted there. A lot of the content is for free. You don't need to pay. A couple of things which are really premium content is paid. And by joining that, you will also get access to the Discord. You will get an invitation if you want to chat with me. Join my Discord. The other Discord that I can recommend is the Candide Discord. The folks are really friendly, and I'm also hanging around there if you want to talk about something. And if you want, well, subscribe to my YouTube channel. I'm trying to keep low frequency but high quality content posted there. You know that by looking at the YouTube channel, the last video that I posted is from October, and I still have a full-time job next to the videos that I'm creating. But join me or add me on LinkedIn if you're looking for me on other social networks. Yeah, that's it. I hope it was helpful, and I hope I will see you in the next one.